Hey, good afternoon. Well, let me start off by introducing myself. Hello, my name is Lance Zurich, and I am the product manager for the Fischertechnik division over here at Studica. And today I'm going to provide you with an overview of the Fischertechnik Education Robotic Competition Set. Now, this set is designed to provide students with the tools and background needed for participating in robotic competitions. Now, this is whether at the local level or even larger scale national and international competitions, things like, for example, the RoboCup Junior. Now, more than that, this set was also designed to enable educators to provide students with a project-based, standards-focused curriculum program which involves inquiry, design, and problem solving. Now, the curriculum for this set, like the curriculum for Fischertechnik's two other curriculum-focused project-based sets, the STEM Prep and the STEM Engineering sets, which are the focus of their own webinar presentation, the curriculum for this set was also created especially for Fischertechnik by noted educator and STEM expert Tom White. So, moving right along here, So what is STEM? Well, most educators are well aware that the term STEM is an acronym, the letters of which stand for science, technology, engineering, and mathematics. Now, if you're involved in any aspect of education, you probably can't open your email box without seeing STEM highlighted in the subject line of at least one of your daily messages. And you certainly can't read an educational journal or visit an educational conference without being bombarded by references to STEM. Now, the reason for this is quite simple. To quote the bipartisan Congressional STEM Education Caucus in their report on the importance of STEM education, STEM education is necessary because it helps to provide the scientists and engineers needed for future development. It provides the future workforce with the skills required of a high-tech world, and it builds the foundation for scientifically literate voters and citizens. Now, as such, STEM education could really be considered a matter of national security. Now, on every level, the world around us is changing at a frantic pace. STEM education, it could be argued, enables us, both as individuals and as a nation, to understand and keep up with these rapid changes in technology, changes which in turn are altering the demands and scope of industry. And obviously, if we as a nation are to keep our stature and position on the world stage, this requires us to keep pace with the rapid developments occurring all around the globe, where countries such as China and India are making major investments in state-of-the-art infrastructure. And while this is all well and good, we should have all, of course, strive to be good citizens, many students might also ask, so what's in it for me? Why do I want to study engineering, or why do I want to study coding, or whatever? So let's consider what it means on the individual level. Well, first off, a few years back, the United States Department of Commerce released a set of projections for the decade leading up to 2018. Now, these projections indicated that STEM occupations would grow by 17%, compared with 9.8% growth for all other occupations. Now, in March of 2017, the Office of the Chief Economist released a STEM Jobs 2017 update, which looked at how these numbers played out up until the year 2015, with 3 years still left in the initial projection. Now, what they found then, when they were checking the numbers back in 2015, what they found was that while the projected STEM growth up to that point was a bit less than expected to be reached by 2018, at that point they had reached 14% instead of 17%. The actual growth for non-STEM jobs, which again was expected to be 9.8%, was instead only a fraction of that, 1.7%, a stark difference. Now, here's a statistic I like to share that I'd give anyone entering the job market of the future pause. Now, this statistic comes from J.D. Chesloff in his Education Week article from March of 2013. Quote, across the country, across all occupations, there are 3.6 people for every one job. In STEM fields, there is one person for every 1.9 jobs. Employers can't find the talent to fill these jobs, which is even more surprising considering that the U.S. Census Bureau recently reported the median salary for engineering majors was the highest of any profession, end quote. Now, as Chesloff goes on in the article to state, quote, supply is low and demand is high. There is a mismatch between projected future jobs requiring STEM skills and the projected supply of qualified workers to fill them, end quote. Now, going back to the STEM Jobs 2017 update released by the U.S. Department of Commerce, which I referenced before, here are 3 key points mentioned in that report that are well worth keeping in mind when considering the importance of STEM education to the worker. Key point 1. STEM workers command higher wages, earning, on average, 29% more than their non-STEM counterparts in 2015. Key point 2 relates to the fact that many graduates with STEM skills may not always end up in what are strictly considered to be classic STEM jobs, things like being a scientist or an engineer. Quote, STEM degree holders enjoy higher earnings, regardless of whether they work in STEM or non-STEM occupations, end quote. Now, there was a video I saw recently on YouTube posted by the Women's Forum for the Economy and Society, the title of which really summed things up pretty nicely, and that was, Every Company is a Tech Company. Essentially, what students want to keep in mind is that whatever a company makes, whatever a company sells, or whatever service it performs, at some point STEM skills are required to help that company fulfill their mission. Going back to the report, key point number 3 relates to job growth. Employment in STEM occupations grew much faster than employment in non-STEM occupations over the last decade, 24.4% versus 4% respectively, and STEM occupations are projected to continue to grow by 8.9% from 2014 to 2024, compared to just 6.4% growth for non-STEM occupations. Now, the trick for educators is to find methods for getting students involved with STEM, and in particular, the most highly in-demand technology-focused skill areas like engineering and coding, and getting students involved in a way that engages their interest and creativity, while at the same time developing good work habits, the way of approaching problems, and the skills that they will need to draw on as they move forward in their careers, both academic and in their working lives. Now, most experts agree that one of the most effective methods for teaching STEM is by providing exercises where certain results will occur, and students have to discover why they occurred, or where students have to find a way to achieve a specific outcome. Now, they do this through experimentation, through research, and through trial and error activities. In short, they find the answers to these questions through the use of hands-on, project-based learning. And that brings us to the focus of the webinar, which is, of course, the Fischertechnik robotic competition set. Now, this set is one of 3 different standards-focused project-based sets currently available from Fischertechnik. The other 2 sets, STEM Prep and STEM Engineering, are the subject of another webinar presentation, so we, of course, won't delve into those too deeply here, instead focusing on the robotic competition set. But in any case, each of these 3 sets have been designed to provide a guided, project-based learning experience complete with detailed curriculum and, of course, using the unique Fischertechnik building system. So, what is Fischertechnik? Well, just to provide you with a little bit of background, Fischertechnik is a flexible and innovative construction system. Now, unlike other popular construction sets that are designed just to simply stack, Fischertechnik was created with more of an engineering mindset. And what I mean by that is the core building block is unique in that it allows attachment from all 6 sides. Thus, it allows for almost limitless design possibilities. Now, many of the parts are designed also to slide together and lock in place, and the hundreds of different parts available will help you to address very specific design needs. Fischertechnik was created back in 1964 by German inventor Arthur Fischer, and he's noted for countless innovations used in both the construction and the automotive industries. Arthur Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison. Now, besides Fischertechnik, Mr. Fischer was the inventor of synchronized flash photography back in 1949. As well as the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to anchor heavy objects to walls. His company, the Fischer Group, employs thousands worldwide, producing many variations of fastening devices used in building construction, as well as various components used in the automotive industry. And they also provide consulting services in regards to various manufacturing processes. Now, I'd also like to mention that Fischertechnik was the very first construction set to offer the ability for students to build and program their own robots using the original pre-Macintosh era Apple computers. Now, almost since its inception, Fischertechnik has been used by middle schools, high schools, colleges, and universities all around the globe to explore STEM-related concepts, things like robotics, renewable energy, mechanics, optics, physics, pneumatics, and so much more. Fischertechnik has also been used by numerous companies, including companies like Porsche, Daimler Chrysler, and BMW, just to name a few, for industrial simulation and training purposes. Now, in addition to that, over the last few years, Fischertechnik's line of pre-assembled simulation models have found wide adoption for demonstrating and exploring the world of IoT, which is also known as the Internet of Things. And this is where industrial processes can be monitored and controlled from the cloud. Now, as such, more than being just something that students would only use for a year or two in their development, you can really think of Fischertechnik as being designed so that students can grow along with it. As students progress through their academic careers, they can also progress through the various levels of Fischertechnik education solutions that are available. Now, the Fischertechnik robotic competition set is designed to provide educators with a clear and detailed pathway for exploring the subjects of robotics and coding through the focus of learning how to create mobile robotic models for use in a competition setting. This set is designed for use by teams of 2 to up to even 4 students at a time. It contains 670 components, all of which come packed in a sturdy plastic gratinol storage box. Now, the set is designed to provide all of the materials that you'll need, and by that we mean both the physical and the instructional materials, to enable teachers to offer a complete, standards-aligned, curriculum-based, competition-focused class or after-school activity. The curriculum used with the Fischertechnik robotic competition set was created especially for Fischertechnik by a man named Tom White. Now, Tom is a noted educator who's been involved in STEM since the 1970s, and he's known for designing programs for educational institutions and for industry. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other topics to the classroom. Now, currently, Tom is involved with the STEM-focused Southern Regional Education Board's Advanced Careers Program, which launched in 16 states back in the fall of 2014 and continues to add programs and participants. Now, this is not the first time that Tom White has created curriculum around Fischertechnik. Besides also being the creator of the curriculum used in our elementary-focused Introduction to STEM series, as well as the long-form curriculum used in the Fischertechnik STEM Prep and STEM Engineering sets designed for use in middle and high school, as well as in higher education, Tom has incorporated Fischertechnik in several educational programs he's designed over the years. Now, the reason for this is Tom believes that Fischertechnik is the ideal construction set for any engineering-based curriculum program, and he's given us several reasons for this. One of the things he likes is that the materials can be used and reused. Things that are built can be taken apart and reassembled into something completely different. It also makes it much more economical than purchasing an expensive piece of equipment that might only be used for 1 or 2 experiments or projects and then put on a shelf until the next semester's class. And it should also go without saying that Fischertechnik, with its wide assortment of very specific parts and components, offers almost limitless creative opportunities. Now, when Tom White designed the curriculum for our 3 project-based learning sets, of which, of course, this is one, he had several goals in mind. First, based upon his observation that various types of teachers have different strong points, for example, he'll often say that he sees his own strong point as being the creation of curriculum such as this more so than, let's say, conducting a lecture. With this in mind, he focused on creating detailed curriculum that would provide a broad foundation of tools for all types of teachers to be successful in providing this class, so that they could instead focus on the needs of the students. He made sure to include a special tutorial section at the beginning to familiarize new users with how the unique Fischertechnik system works. And he made sure that each section of the curriculum clearly spells out how everything will be addressed in that specific unit. In short, he designed the curriculum and selected the components included in each set to essentially act together as a turnkey solution that would provide everything teachers should need to deliver the material effectively in one place. Now again, the curriculum was designed to provide a clear roadmap for both the teachers and the students. The goal was also to enable teachers to provide students with engaging curriculum-based projects that had an authentic objective in solving real-world problems and which contain embedded academics. The detailed curriculum with this set, if followed, provides the basis for what could be a standalone project-based robotics class or an ongoing after-school activity. Now, under this project-focused model, students are told upfront what they will need to learn and understand. They're given a real-world scenario where they will take on the role of a professional working on a team which has been presented with a design challenge that they must devise a solution to. And they are also provided with different tools and pathways to allow them to achieve this goal. Now, among other things, students must perform research, and this is research both inside and outside of class. And they learn the documentation process, things like creating a design brief, maintaining a digital engineering journal, and so on. And they'll learn about collecting data. They're going to learn firsthand how data acquisition works. They're going to learn how to process data. They're going to learn how to put the data into graphs and other formats, and so on. Students are given a technical literacy task driven by the project. Fulfilling this task will require them to gain the knowledge and tools needed to address it through research and exploration. Students will perform a series of specially designed enabling activities through which they will acquire the necessary science, math, and tech-based skills. They will devise solutions to their tasks and create prototypes using, of course, the advanced Fischertechnik modeling system. Students will then create and install the programs needed to control their prototypes. They're going to need to document every step of the entire project, and at the conclusion of each project unit, each group of students will be required to formally present their findings, including a demonstration of the prototype in action. Now, the curriculum itself comes in the form of a 576-page downloadable PDF document. This document, which we're going to look at shortly here, contains detailed academic material for use in a classroom or after-school setting, as well as full-color step-by-step assembly instructions for building a series of 20 different models. Now, these assembly instructions are included both as part of the PDF documentation, and they're also included in a physical printed form inside each set. Now, as many educators and students may be new to the Fischertechnik building system, once again, the curriculum PDF also includes a helpful tutorial section at the very beginning to help both students and teachers to quickly get up to speed with using the system. Now, this section covers such areas as how to identify the various parts being used, to learn how they fit together, and even walks you step by step through the building of a simple model. Now, the curriculum itself is divided into 4 main project themes, and these project themes or units focus on competitions, programming, sensing and vision systems, and mobile robotics. Now, the curriculum as a whole is designed to provide enough academic material to cover approximately 70 hours. Now, according to program creator Tom White, there is room here for educators to be a little bit flexible with this. As he pointed out to me recently, a teacher could choose to leave out some things and use this to fill approximately half a semester, assuming a daily class period of 50 minutes, or they could add some hours of experimentation to easily bring it up to 90 hours or so if they chose to. Now, during the course of the 4 project themes, various activities are also addressed and various subjects touched upon, and this includes things like sketching, schematics, Ohm's law and power, an introduction to using the RoboPro software and the TXT controller, flowcharts, open loop and closed loop programming, digital branching, edge triggered versus level triggered, logic gates, combinational logic, analog branching, variables, data, sensors such as the digital switch and the digital photo transistor and the digital trail follower, analog sensors including the NTC resistor, the photocell LDR, and the color sensor, as well as the ultrasonic distance sensor. An introduction to using the camera to detect motion, working with color detection, creating a ball finder, which involves using the swiveling camera, working with the line tool and the encoder motors, and building the control panel. Now, I'd also like to point out that the curriculum for the Fischertechnik robotic competition set has been designed to address some of the most widely recognized academic standards currently in place in the United States. And this includes the college and career readiness standards for math, science, reading, and writing, the NSES content standards, standards for technological literacy, ISTE standards, and the next generation science standards. Now at this point, let's look very briefly at some of the actual physical materials included in the Fischertechnik robotics competition set. Now as I mentioned previously, each set contains 670 parts and components. Among this, it includes a license of the RoboPro graphic programming software, which is for Windows-based systems, the powerful and compact Robotics TXT controller, which has a full-color touchscreen, has Bluetooth and Wi-Fi connectivity, programmable sounds, and all sorts of other things, and also a Fischertechnik rechargeable NIMH battery pack and charging unit, and this is used for powering all of the models. Now, among the special components included is a gyro sensor, which is only available in this set. 2 encoder motors are included, a USB camera attachment for building robots with vision systems and those types of capabilities as we mentioned before. A photo transistor is included, an access motor, 2 push-button switches, a color sensor, an NTC resistor, 2 LEDs, 3 ultrasonic distance sensors, an IR trail sensor, a photoresistor, a reed contact, and of course hundreds of other parts of various types, all packed in that sturdy plastic Ratinal storage box. Now this set also includes printed materials such as the full-color 74-page pictorial assembly manual, which includes instructions for building 7 different stationary and 13 different mobile robotic models, a total of 20 models in all, and also included is a printed sample track and a side fence to use for competitions. Essentially, even if you chose to ignore the standards-based curriculum that's included with this set, you could still view this as the ultimate Fischertechnik mobile robotics set. The contents of this one box will allow you to build all the models found in both the Fischertechnik Robotics TXT Advanced set and the Robotics TXT Explorer set. Again, everything students will need to build all 20 robotic models is included here. And that includes the programming software, as we mentioned, the controller, the power supply, and of course all of the parts that would be needed. Now, as I've mentioned several times that this set would allow you to build 20 different robotic models, let's just take a quick run through those models. Again, please note that these are, of course, not the only models you can build with this set. And in fact, each of the 4 project themes in the curriculum will really only use these models as, at best, a reference, and instead will require students to design and build their own original models to solve the core problem that's put forth in each unit. That all being said, this one set will still include all of the parts required as well as the detailed step-by-step instructions for building each of these models I'm going to show you, which can be studied and experimented with on their own or used to help students to explore and understand the concepts that they're going to draw upon for their own unique projects. You have things like the ventilating fan, a temperature control robot, an automated hand dryer, a traffic light simulation, a parking barrier, a swiveling security camera with an alarm, the cameraman model, a basic mobile robot, a hindrance detector, one with a camera, a trail searcher, a detection robot, a soccer playing robot with movement control, and then a soccer playing robot where it's all incorporated, a basic tracked model, a trail searcher, a tunnel robot, a color detector, an explorer robot, a rescue robot. Now let us turn our attention to the curriculum itself. Now at this point, as we've already established the themes and concepts the robotic competition set will help you address in the classroom, let's now take a look at how the curriculum itself is structured. Each of the 4 project themes focused on in the curriculum for the robotic competition set contains a roadmap of sorts, where each of the following elements are addressed: the purpose, the concepts, the student deliverables, assessment and evaluation materials, an outline, the standards, an authentic project scenario, the daily teaching plan, supporting activities, and resources. Here's the table of contents for the robotics competition set. Now, the first thing I would like to note is the section right at the beginning that I mentioned a couple times previously, which is designed to help new users of the Fischertechnik system to quickly get up to speed. Now, again, the core building blocks in the Fischertechnik system are designed to attach from all 6 sides. And many other parts are designed for very specific purposes. Now, again, as this is different from the simple stacking construction of many other building sets you might have used before, we've included this tutorial section right up front, both to increase your comfort with the system and to allow you and your students to get the most from your building experience. Now, there's a section showing you how the parts fit together and discussing the pin and groove assembly method that's used throughout the system. A section showing you how to identify the different parts from the core blocks to more specialized pieces, things like clip axles, girders, rivets, angle pieces, and much more. And for those educators who are new to conducting a class of this type, there is a chapter specifically discussing project-based STEM education. Now, after this introductory section, we have the 4 theme units, which I introduced earlier in the presentation. Again, these are competitions, programming, sensing and vision systems, and mobile robotics. Now, in the following slides, I'm going to share some examples from these 4 units, these 4 theme units, to show examples of how they address the structural format that I touched upon a few slides back. Each theme unit will start off with a section outlining the purpose of the project to be addressed in that particular unit. Now, this is the section that spells out for students a clear answer to that eternal question, why are we doing this? As well as what skills we hope to develop. Now, in the example shown here, this is taken from the unit on programming, and the focus will be on students designing and implementing a program to control an automated system. Now, this is followed by a section listing the concepts to be addressed in this unit. And these are the big ideas that students should learn from this unit that are going to be useful and vital for them to understand and know, not only in completing their projects, but things that they're going to need to draw upon as they move forward in STEM fields of study, and we would, of course, hope STEM-related careers. Now, this particular section, which you see on your screen, is taken from the unit on competitions, and it provides an overview of some of the areas students will begin to learn about and explore here, such as, for example, control statements, linkages, mechanisms, automated systems, sketching, and much more. Next is the outline, which is found in 3 of the 4 theme units. Now, in the outline, it's spelled out more specifically what will be covered in that particular unit. Now, the example pictured on your screen here is taken again from the unit on programming, and so you'll see things listed here such as documenting programs, working with object blocks, Boolean mathematics, loops, branching, data, and so on. After this in each unit, we enter the section where each of the specific standards to be met by that particular project unit are spelled out, which of course provides the educational justification for whatever project we're doing. Now, we often get asked if our curriculum-based programs meet the standards for a particular state or district, and of course, while we would love to be able to state that they do, with 50 states and so many different districts in each state, being able to clearly align to all of these individual standards, of course, isn't really practical or feasible for us to do. So instead, what we've done is we've selected the most universally accepted standards that are currently in place in the United States. For example, we start off with the College and Career Readiness Math Standards. which are followed by the reading standards for literacy in history and social studies. After this, we get into the writing standards for literacy in history, social studies, science, and technical subjects. Next up, we have science standards, beginning with the NSES content standards for K to 12, the standards for technological literacy, and that's followed by the ISTE Technology Foundation standards for students. Next is an assessment section with links to both general course rubrics as well as rubrics related to that specific theme unit. Following this, we have what we call the essential question, and this can be thought of as the major idea that's going to be explored in the particular unit. Now, in this example, which is taken from the unit focusing on sensing and vision systems, the question put forth is, how do automated devices sense and interpolate the world around them? The student scenario for each unit gives the students an opportunity to explore that particular unit's essential question, and this is done in the form of a real-world problem that they're given to solve. And it also provides an answer to that eternal question we mentioned before, where will I ever use this? So anyway, in this particular example, students are told they are part of a technical sales team working for an alarm company. And to quote from the scenario, quote, "Your company has been trying to increase sales to the museum alarm manufacturers. The decision has been made that sales could increase if there was a web page created that had a section for each sensor, a description of how it works, and a sample alarm circuit that others could use to base designs from. You will have to build a prototype of the situation your alarm will monitor and list conditions you will monitor. A section on suggested calibration is also necessary. Your team has been charged with this project. Your team will brainstorm what the web page should contain and how it should be laid out. Your team will conduct internet research to discover how sensors work, what other companies do to create data sheets, and how to create simple web pages using Microsoft Office. Once the research is done and the enabling activities are completed, the team will design their sections for the web page. Any software created for the web pages should be documented completely so another team can easily figure out the work you have done. All work should be documented in the engineering notebook. Students will devise alarm circuits utilizing at least 3 methods. Each sensor will have a page in the manual, and the sample alarm circuit should explain how each sensor works and sees things the others do not. Students will present their online files along with a presentation of their prototype in hopes of landing a sales contract. Now, in another scenario, which is put forth in the programming theme unit, the student groups will be tasked with designing and building an elevator that will need to function in a particular manner, such as how it will respond to a call button being pushed on different floors at the same time. Now, each student group will be tasked with designing and programming protocol for how the elevator will navigate such occurrences. For example, does it go to the top first or the bottom first if it's on a middle floor? And again, the fictional client's requirements are clearly spelled out, and the students will be required to create a program to address these specific needs. They're going to have to create a physical prototype using the Fischertechnik components, and of course, prepare a presentation for these clients that includes a demonstration of both the prototype and the program in action. Anyway, after that, we get into the daily plan, which clearly spells out the expectations the students work through the project in the student scenario. Now, each day of the plan acts as a guideline to spell out specifically what the students will need to look at that day and what everyone needs to accomplish. Now, you'll see here that as different concepts are addressed, students are provided with helpful links that will give them more information. For example, they're going to have links showing them what's going to be required in the design brief or the engineering journal that I keep mentioning. Now, once again, each day has a different task to be addressed. It has a different activity to perform or a different question to answer. Now, in the example now on your screen, again taken from the unit on programming, if you look at the bottom there for day 7, there's a discussion topic, which is, how does my dishwasher know when the dishes are clean? Which, of course, your dishwasher doesn't know when the dishes are clean, but it's programmed a certain way to go through certain cycles for a specific period of time. And so here the teacher will lead a discussion where this idea can be explored. Now, other things that are covered in this unit, for example, will include how data is taken from the sensor and recorded, how files can be taken from the RoboPro software format and put into an Excel format to be worked on and then put back into the RoboPro format, and other things like this. Now, as students work through the daily plan and on their answers to the student scenario, they're going to be required to perform research. They're going to do trial and error experimentation while documenting the entire process. And again, this means maintaining a design notebook and an engineering journal. And again, they will design and build a working prototype where required using Fischertechnik, and also create and deliver a presentation of this prototype in action. Now, this curriculum is designed so that each day in the project theme builds on the one before it, and each activity is subsequently more complex, and along the way provides the information that they're going to need to draw on to successfully complete the project in the unit. Now, this really helps to reinforce the concepts for students, and it ties everything together in an organic and meaningful manner. Now, there's also a section at the end of each unit where various additional materials are collected, and these can be things like vocabulary words, which are included for each unit, links to carefully vetted web-based resources, Word documents, PDF files, and PowerPoints. And once again, each of the 4 project theme units follow the same structures we've just seen, including the standards, the rubrics, the daily plan, the resource materials, then links, and so on. And as I mentioned before, there are also numerous links throughout the curriculum for more information on specific topics that arise, all of which are collected in one section at the end of the robotic competition set curriculum. And this is going to include activity links for things like sketching, schematic drawings, Ohm's law and power, an introduction to working with the RoboPro programming software, and becoming familiar with the TXT controller, working with flowcharts, open loop, and closed loop programs, digital branching, logic levels in programs and triggering, logic gates, combinational logic, analog branching, variables, data, sensors such as the digital switch, the digital photo transistor, and the digital trail follower. And next we move on to analog sensors, things like the NTC resistor, the photocell LDR, the color sensor, and the ultrasonic distance sensor. An introduction to using the camera attachment, using the camera to detect motion, color detection, using the swiveling camera as a ball finder, learning how to have the robotic models follow a line path, learning how an encoder motor allows for precise control of movements, and building the control panel. And as documenting the entire process is a major focus of the curriculum here, there's also another section included at the end of the curriculum that spells out the proper procedures for record keeping of the sort that we've been talking about. And this is designed to help students to develop proper work habits, and it embeds the technical literacy into the projects, such as, for example, the engineering notebook. The requirements for maintaining an engineering notebook are clearly detailed. The elements that make up the design process are outlined. Examples of design documentation are discussed. The problem statement is explained, including its components, the vision statement, the issue statement, and the method statement. Points to be summarized in a design brief are discussed. The elements of testing protocol are outlined. And finally, the required components for an engineering report are also clearly outlined, as well as the project-themed rubrics. Hang on a second here, we got ahead. There we go. And finally, this is followed by a section collecting the step-by-step assembly instructions for each of the 20 models, which, as I mentioned, is also included in printed form in this set. There's another screen. And that is everything you get included with the Fischertechnik robotic competition set. So just to summarize, the Fischertechnik robotic competition set contains everything you need. That means all the parts, the RoboPro graphic programming software, the compact and powerful Robotics TXT controller, the rechargeable AccuSet battery pack and charging unit, all the step-by-step assembly instructions for building 20 different instructional models, and complete and highly detailed day-by-day curriculum. And the curriculum included in each set is yours to use this year, next year, and for many years after that. Just to be clear, there are no additional fees, there are no subscription charges. Everything you need is included. Now, each set is designed, again, for use by teams of 2 to 4 students at a time, so it's easily scalable. And by that, what I mean is, let's say a classroom of 20 students could use as many as 10 or as few as 5 sets, depending upon your budget and how quickly you want the students to move through the educational material. And again, all of the parts are reusable. You can build a model, perform the experiments, take it apart, and build something else. And of course, if you ever did need any odd parts or any replacement pieces along the way, you can purchase those individually in whatever quantity you choose or need directly from our website. Again, the Fischertechnik Robotic Competition Set is designed to make it easy for educators from any background to offer a hands-on, project-based learning experience for their students. Now, once again, this is what experts agree is one of the most effective methods known for teaching STEM concepts like robotics. Now, the pricing on these sets starts at just $6.99 per set, and of course, if you contact us, quantity pricing for classrooms is available upon request. So with that note, if you do have any questions, this will be the time where we will open it up. If you'd like to type in any questions in the chat window located in the Join Me toolbar, if you just look for the little word balloon icon, you can click on that. It will open up the chat window, and you can, of course, feel free to type in there. You can also email your questions to me. My email address is on there, lancez, L-A-N-C-E-Z, @Studica, Studica.com. Or once I unmute things, you'll be able to speak in real time. So just give me a second here.
Everyone can talk now.
So if anyone does have any questions, you can feel free to let us know now. Again, you can just, if you wanted to speak on the call, you can speak on the call. You can use the chat window, or if you'd rather not do that now, you can, of course, again, feel free to use the email address that I provided. That goes directly to me, and I will, of course, get back to you very quickly on that. So if you do have any questions, just let us know. Once again, my email address is lancez@Studica.com. So on that note, going once on questions, going twice on questions.
Only the host can talk now.
Well, on that note, I'd like to thank you for taking the time to attend today's presentation. Now, if you would like to know more about the Fischertechnik Robotic Competition Set or any of our other STEM-related sets, and this includes things like the Introduction to STEM series for elementary students, the STEM Prep and STEM Engineering sets, which I mentioned earlier, which once again are the other 2 standards-focused, project-based curriculum sets from Fischertechnik, or even if you'd like to learn about our line of industrial simulation and training models. If you'd like to request a quote or speak to one of the dedicated educational representatives, you can simply call us at the numbers you see on the screen now. In the U.S., our toll-free number is 888-561-7521, and in Canada, you can reach us at 800-561-7520. You can also find more information on the program by visiting our special STEM education page on the Studica website, and that address for that page is www.studica.com/Fischertechnik-education. Or, of course, you can email us. Our general email address is STEMLab, that's STEMLEB, @Studica.com. Or if you have a specific question about what I've discussed today or anything else Fischertechnik related, you can also email me directly at lancez, Lancez, @Studica.com. Once again, thank you very much for attending, and have a great afternoon.